Okay, so I want to talk about sort of work I've been moving towards about designing more than just the executable. So often you have a project, and this is what it looks like. So this assumes message handlers, because I program entirely by message handlers that send messages to each other. And the executable might be quite complicated, but it's a single the executable. And it'll usually have some kind of main bit, and then it'll have components that often talk to different types of hardware. And you might have 4, 5, 6, 7 types of hardware. And it all wraps together in one executable. And then when you think about, but the idea that I want to talk about is the possibility of having more than one executable, so your hardware and your stuff is distributed, not necessarily on different computers, just basically on the same computer. So here I've done it where I've added another component, D, but rather than adding it to the big mix of everything in the executable, I've put it off in its own executable on the side, and then I want to talk to it from the main executable and use it. And the reason you might do that, I mean, the most obvious thing to do that, of course, is you need to put that on a different computer. So your only option is a separate executable. But there's reasons why actually you might like that anyway, even if you're running it on the same computer. So one simple example is different bitness, or different, like you have I had a customer who, they had 64-bit LabVIEW, and they wanted to add a piece of hardware that only had a 32-bit driver. And so, like, I mean, you're stuck with that. But putting it in a separate, it was quite a simple thing. It just basically was monitoring the room environment, temperature, humidity, and so on. And putting it in a separate executable, you can use 32-bit and just send the information, no problem. Another one that I find a lot with, I work with people who have lots and lots of hardware. They all got to work together. And often, you're working on one piece of hardware, so you got to stop it and start it as you change things. But another bit of hardware takes like 3 minutes to stop and start. Like it has a big complicated procedure of moving things, and getting back to where you can test it is really, really painful. And having separate executables means they can start and stop independently. So you can start one thing, get that all ready, and then start and stop the thing you're working on very quickly, and actually then it increases your development. Another thing to think about is sometimes I've worked with stuff that uses third-party DLLs that do complicated calculations, and sometimes you have a problem that they occasionally crash. And if you call a DLL and it crashes the whole executable. Hard dead. But if you put it off in a separate executable, then it's kind of like sandboxed. And it can crash, and if your main program is not crashed as well, and you can restart it. Or at the very least, you haven't like crashed some important thing that can't crash. And then another thing is often you want to use it by itself. So you might say that, this is a piece of hardware, someone wants to operate it by itself. I do a lot of work with like sort of R&D companies that are sort of developing things. And although the idea is it all works together, in practice, they're doing different things with different bits at different times. And so having different executables for different bits of hardware works really well for the workflow. And then another thing is you can actually share it between apps. So you have one piece of hardware that if it's providing information, both apps can actually get the information at the same time. If it's doing something, then at least you can run one app, stop that app, and run another one. And again, if this one in the middle takes a long time, I mean, imagine a furnace that takes like 20 minutes to heat up or something. Again, that can give you a lot more flexibility. So all this, of course, this is all based on, unless it's on a different computer where you're forced to do it, the other things you're only going to do if it's easy or if it's relatively low cost. And so, I mean, I don't know if I'm saying something. I always have viewed switching to TCP as kind of like a costly thing to put it in. I don't know if people would accept that as being reasonable. But what I'm trying to do is get it towards that. Putting something in a separate thing is relatively low cost. It's not no cost, but it's low cost. So that you think to do it for a wider range of reasons. So this is an actual thing that one idea is to have a test the executable. So the main executable, of course, is the important thing. And I have clients that they want to test it. Of course, we have tests on the code itself, but they want to test the executable in the actual hardware. And so this test here shows the idea the test executable pulls a bunch of standard data, has a means to connect to it, inject the data, and then look at the output of the main executable, and then test that it is correct. Right? And that's a test on the actual hardware you're running on with the actual compiled executable rather than source code. And they can run it multiple times themselves. I find customers like it much better if they can run something that says it passed rather than me tell them that I've run tests and they pass. And then finally, there's another client, the same client actually that runs those tests. Actually, I should say another test that the same client does is, again, there's more than one of these test executables. One of them, they leave running for months. It goes for months, and it injects commands. It puts the main executable through its paces, reads the results, makes sure they're correct, and tries to find errors that occur periodically. The main executable is something that must run for months unattended and must recover from any kind of failure, and call several third-party executables that can crash. So it's actually quite difficult. So what we have is, again, another executable is a watchdog. So the main executable launches a watchdog, and the watchdog's job is just to watch the main executable and make sure it's working properly. And if it's not working properly, or it crashes, or it gets stuck, it will kill the main executable and restart it. Right, so and it's basically, it starts, it registers the main, says, just periodically tell me when you're taking data. And if it doesn't take data for a certain period of time, or it can't connect to it, then it's failure, and it tries to kill it cleanly. If that doesn't work, hard kills it, and then restarts it. And if that doesn't work, it'll restart the computer and try and so, I mean, it really goes through a set of recover because no one's paying attention. Okay, so this is a more standard reason you have TCP in that you have quite a bit of hardware that is in on more than one computer. This is an application for Rutherford Appleton Lab where they are part of what's called the Total Carbon Column Observing Network, which is a network of things that use sunlight traveling through the atmosphere to measure carbon dioxide and things in the atmosphere. And so they require trackers, which is a solar tracker which tracks the sun, directs the sunlight into their spectrometers. And they have multiple different spectrometer technology types. So in this one, they got a weather station because they got to know what the weather is. They got to know it's sunny, not raining, not too windy. And then they can open the dome, which is one of these domes on the roof. That exposes more than one type of tracker, solar tracker. And that tracks the sun across the sky using mirrors and cameras and stuff. And then they have spectrometers that can only run when they're having sunlight directed onto them. And so this was implemented by a series of different executables. The weather station runs all the time. So it's like it doesn't start and stop with the spectrometers because they want to monitor the weather all the time. So it's just running. The dome also runs most of the time, and it's connected to the weather station, so it knows when it can open. And then the trackers, they only run some of the time. And when they run, they want to connect to the dome to know, am I open to the sun? Am I expecting to see the sun? And then the spectrometers want to know when the trackers are tracking and actually directing sun to them. And so again, this is distributed over a number of computers, 2 or 3. And so again, this is all TCP connections. And you want this kind of stuff to be easy. You could have put this all in one executable. I mean, you'd be tied to one computer. But it would be a massive executable. And it was much better to have these all separate. Oh, another fact is that testing. So if you have someone who's really critical about if you change something, you've got to go through a huge test procedure. Having separate executables really helps because you change one executable, you only have to do the tests on one executable. Okay, so I use something called messenger library. It's the main way I develop applications when I have a choice. It's been around for like over a decade. It's free. It's on the Tools Network. There's a series of YouTubes which sort of you can go through and it develops a project. I'm actually going to show that project later on. It's sort of its documentation. So I'm going to go through messenger library just very quickly. So messenger library is based on the central idea that often you want to send a message to an address, send a message somewhere. And you think, well, we already do it in a LabVIEW because you can put things on a queue, you can send it to a user event. But actually, that's more specific. So in messenger library, there's a more generic address, which could be a queue, could be a user event, could be TCP. That's the idea. And the idea of making TCP easy was one of the original reasons to do messenger library, although it got put on the back burner a little bit. Because you can write code, and that's the simplest thing you could write, which is just, I've got an address and I want to send a message to it. Now, it's extremely simple, but that can send to TCP because the address is generic. It could be some method to send by TCP, right? And the idea is that if you have something and you want to make it so that it's distributed among executables, most of your code doesn't need to know, doesn't have to be rewritten, right? I want to be able to say, oh, I need this on another computer, or it'd be good if this was separate. Then I can make changes quickly and have it work without having to rewrite things extensively by using a different communication technology. If I use a queue, fine, works. If I use a user end, works. Another thing about Messenger Library is it's built on the idea of replying to messages, kind of like email. So I send you a message, you reply to the message. That means that these addresses are sent in messages and are used to send replies back. And it also uses notification. Notification is a special kind of reply. So rather than I send you a message and you reply to it, I send you a message saying, please keep me informed about this. And then you send me a series of messages whenever that thing changes. So it's basically a message stream. But it's basically, it is still a request to reply. It's just there's multiple replies. And then finally, part of the Messenger library is called translation. Translation is where I say, rather than I'll send you a message, send me temperature, the temperature. I want you to send me temperature, but label it furnace temperature. So I know what it is. I'm basically telling you how to send information back to me. And sort of examples of that are, send to a queue, send to a user event. That's the basic. Use different technologies. Add prefix from one and send to this queue. That's basically label this message so that I know what to do with it. And then another one is like, I can say, please label your message temperature, and then send copies to two places. But in one place, say main. And I mean, I can build up more complex things of routing messages. So that actually makes the, it promotes reuse because I can start off with a very simple component that just sends temperature. Right? It sends temperature, a temperature notification. But I can reuse the component in a more complicated app where I want the temperature to go two places. And I can rename things. So for example, main can get temperature from two copies of the component and relabels the temperature messages as prime temp and auxiliary temp. Right? So the messages come back labeled. So it keeps the components quite simple. I don't have to build this intelligence into the components. The high level says, OK, I'll configure the component by sending, please tell me the temperature relabeled this way, and so on. OK, now let's talk about TCP with Messenger Library. So again, this is the thing I showed before. And the TCP, of course, is all the blue ones, where the things must connect. Say, I am interested. The DOM says, I'm interested in the sun, the wind, and the rain. Please send that to me. That's a register for notifications. And then the weather will tell it whenever it's sunny or not sunny, when the rain starts, so on. How that actually works internally is that's the server. We use client server with TCP. The server starts a listener, TCP listener. The client starts what's called the TCP client actor, the thing. And that has two loops, and it connects to the listener. The listener launches a connection. And then you got two pairs of loops that sort of are both the bidirectional sending the messages. And then the app sends the message through across and back. And the replies come back and notifications. Oops, that's annoying. Time for stand-up. But anyway, so that's complicated because there's lots of loops. But it's not complicated because as far as the two things at the end, it's like that, right? They don't know it exists. You don't have to do anything, right? As far as the client's concerned, it's exactly I'm just sending to an address, making a request. And the app is just replying to the message or making notifications, and they go back. And they do not know they're using TCP. It's exactly as if they were in the same executable. But there is a slight complication. And the question is, well, there's two executables. They are independent lifetimes. Who starts first? And also, TCP communication, at least between computers, is unreliable. It could be disconnected. And it can be disconnected temporarily. And are we connected or not connected? So this is different. So normally in an executable like this, again, main creates C. It knows it exists. It knows it can talk to it. It can expect its messages to be received and replied to, right? Because it owns it, and it created it, and it starts and stops it. But once D created, well, someone else starts it. Someone else has to start the executable. It might start before or after. It might temporarily go down, stop and restart, or temporarily, someone unplugs the cable and you can't talk to it temporarily. And this introduces complexity. Now, I want to make it so it's easy to have separate executables. And this is the complexity that makes it hard, because normally you don't have to worry about these kinds of things in one executable. So now I'm going to go through some examples that come with Messenger Library mostly, except one example, which is the YouTube example, the one that's described in the YouTube videos. I'm going to modify it. I modified it so that it works, so that instrument 1, which is one of the things creating the data, is in a separate, not executable, a separate project. Because a separate project is like a separate executable, because you can only talk by TCP communication rather than other things. Oops, where are you? Come back here. There. This is the point where computers crash in talks. So first I'm going to talk, this is the example that comes in Messenger Library of the communication. So is the screen big enough? Can you see that? So basically this is very simple. So the communication for a server is mostly one VI. So this loop communicates with a queue. It's a queue-based thing. But it's a network-capable queue. So messages that come in over the network will be injected onto the queue and it can handle them. The queue, the loop part has nothing to do with TCP. It's just basic Messenger Library stuff. All that is different is the first bit, which basically says, please be a TCP server at that server address. So I can start one of it. Hang on. How's the time, by the way? 20 minutes, okay. So here's a client, and I start the client. And you can see it shows connected to server 1. And it comes in. And if I stop server 1, disconnect it and restart it, it connects again. This one actually is using UDP messages as an address discovery. So basically, when it starts, it starts sending out UDP messages saying, I am service so-and-so, and the client is listening to those. That's sort of that's why it's so quick. And then if I start another, I can start another server, server 2. And again, it immediately connects and disconnects. And so the difference is, from whether this was just creating them as one executable, is that, of course, you can start and stop the servers at different times than the client. And you need the client, the connection to connect and reconnect. And you need the client to know this extra state information that it's connected or not. So the complexity is you can't totally make TCP seamless because it's not reliable. You have to know, am I connected or not? Have two states in your client executable, and handle it. So it's a little more complicated, but it's not actually much more. You just got to know that you got to handle the case that you're not currently connected. Let's see. And again, you can start and stop them independently. So another important thing that I find that makes this easy is that Messenger Library is based on notifications, and there's two types of notifications in Messenger Library. One's called an event notification, which you've probably seen in other kinds of packages, which is basically, this happened. Right? The problem with that, I found, is that, and a particular problem here, where you don't know who starts first, is that one thing can start, can make the notification, here's an important piece of information that I'm going to make a notification once and never do it again. And then the second thing starts and registers for it, but it never gets that important message. Right? So it often is state data. So say you had a furnace and the set point was 200 degrees. Unless you change the set point again, that set point is 200 degrees event only goes once. And if you connect later, you can't see that. And then you get inconsistency of the state information between the two things. So in Messenger Library, there is, let me show you this. So here I go, like, I fire notify, and then I register for that notification, and I see nothing. Afterwards, then the events come in. A state notification is basically an event notification, except it remembers what the last notification was. And then if someone else registers for that, it sent that last notification. So if I start that here and do a state notification, a couple of them, as soon as I register, I'm immediately sent that information, right? So if the critical information was the set point is 200, and I register an hour later, I will get set point is now 200, and I will then immediately jump to the correct value. And this solves lots of problems as far as ordering in time and when you registered and all sorts of race conditions. Like it just gets rid of a whole class of problems. So that's done that. Hang on. Projects. Now I'm going to look at this is called the YouTube example. And basically it's a top level starts an instrument actor. The instrument actor is running a simulated instrument. And then data is passed back and forth. And the top level can also open a little user interface. And all the controls, and you can see, are slaved together. Basically, if you change the value of the amplitude in one place, it gets sent to the instrument, and the instrument notifies everyone what the new value is. So it's all tied together. So there's a lot of messages flying by. But it's all, again, it's all monolithic. So if I were to stop the main application, everything stops. And you can't really run it separately. Let's close this one. Hang on. Now I modified this on the train up to GDevCon. And now it's in 2 projects. I can find the right one. So now instrument 1 is in its own project. And that means that any queues or user events it was using to communicate won't work between projects, right? So this is exactly as if you had 2 executables. Cool. Now the only thing I've done, the only thing that I've made, change I've made to this, is that little sub-VI up at the top that says GDevCon 4, which is the TCP service name we're using. That's it. I dropped that in. This thing communicates with a user event, ultimately under the hood. And that little VI means, say, start a listener, and of course a TCP server, that any message that comes on the server will be put on that user event so that this loop can handle it. This loop was unchanged other than dropping in that one VI to make it a server. Let's just run it. And of course, now we can run it by itself. And it's just sitting there doing nothing. Happy, happy. And then we look at the top level. So the top level, when I start it, now the top level, it required more changes. But the only real change, important one, is that, just a sec. Where I say start instrument 1, I'm no longer starting it. What I'm doing is I'm creating what's called a link. Now the link is basically, I want to link to this instrument over TCP. It may or may not be able to exist yet. I want you to try and maintain a link to it. So when you start this, it'll try and link to it by TCP. If it can't, it'll just keep retrying, right? And what it will do is it will, so if it connects and loses connection, it'll keep trying to connect again. So it'll try to maintain a connection. Before, I found with what I had early on is that you had to have complex retry logic because you would lose it, so you've got to detect that you've lost it, and you've got to go try again and restart. And it was a lot of busy work to do in the code to convert. With this kind of thing, it's relatively easy because you just say, I want to maintain a link over here. The one thing you've got to do is here, where I'm registering for what information I want, there's a new registration called a TCP client connection status, basically. And I have to handle that message over here, which is, when it sends to me, it's just a Boolean which says where I'm connected or not. And that's where I can use that knowledge of whether or not it exists, I've connected to the instrument 1 or not, to change how I work. So if I start this, again, it connects just as before, getting the data from back and forth. We can show instrument 1. I can change the amplitude, just like before. Now here's it. I can open this new UI, and I can adjust the amplitude remotely. The new UI, I did not change at all. is exactly as it was before. It has no idea that it's communicating over TCP. It's unchanged. So that's like, I mean, that's what I'm trying to do. I'm trying to make it so that to go to split things across executables is not a lot of work, because most of the code works seamlessly with TCP or not. And there's only a few little things you got to deal with. Basically, it's I'm no longer reliable, I might not be connected, and the startup and shutdown kind of stuff. So, any questions on that? I think it's a good point for questions.
What you're describing basically is kind of microservice architecture.
Yes, it's very similar to microservice architecture.
Yeah, so
you really have to think in that kind of microservices to do it, because you can't have it you can't have the interconnection to the EXCs be too complicated. It's got to be very clear. I'm providing this information. I am asking you to do this kind of thing.
Okay, so and my thought on that was it looks a lot like using a publish subscribe like MQTT or RapidMQ or something like that. So what's the advantage of having that implemented in the library instead of jumping?
I mean, the advantage is whatever you do, whatever your standard way of doing it, have TCP be an easy extension of it. Because you can say, well, I've got all this code and I want to put D over there, but I've written it in a particular way to work, and now I've got to totally redo it with MQT. What is it?
Yeah, MQTT.
Yeah, you got it's a rewrite, right?
Yeah, but it would give you a lot of handling of connections and stuff, and if history of state history, that would be included in that. So I totally understand your point. So I was thinking of DQMH-ish or Active Framework-ish. So it's nice to have that internal link, but as soon as you switch to let's say to an open industry protocol, yeah, you will have the interconnection to worlds like Siemens or so it's back office sponsor. Sorry. Yeah, you will open up your ecosystem.
Do you do that?
Yeah.
Okay, so you're kind of choosing the communication technology that's already at TCP1 and just use it locally when you don't need it.
Yeah.
Okay, that's reasonable.
Yes.
I have a very small question. What is performance limitations?
Mostly what I've done, I have not run into any. But when you do sort of microservices type thing, you don't want to spend huge amounts of data and huge amounts of data back and forth. You wouldn't want to do, you would think about, if you're handling, when I do handle large amounts of data, I handle it as soon as possible to boil it down to something interesting. Even before, with one executable, I don't send the messages between things with huge amounts of data. If I get in a big, huge amount of data, I immediately analyze it and get it down to at least to a smaller amount that can be sent around. That avoids all the cost of copying and stuff that you have. So I cannot give you a good answer. I should actually try and enforce it.
But you said about what approach? But you said about approach.
Any other questions? Or?
I have one,
oh, sure.
if I may. First, I think it's brilliant.
Cool.
Thank you. So yeah, first I think it's brilliant. We're doing kind of similar things for clients. My questions kind of relate to the first one you have. Now what I see is it's always from LabVIEW to LabVIEW, and then if you want to start communicating between LabVIEW and other technologies like PLCs, for example, you have standard ways to do that, like OPC UA, for example. Is it something you considered using? Because it's kind of...
I've used OPC UA.
Yeah.
In fact, the application, the one that runs forever, actually broadcasts information. It's an OPC UA server. I found that really, really a lot of effort for OPC UA, the way it was done. But
so here, if you need to...
I would not use that LabVIEW to LabVIEW ever.
Okay. So basically here, if you need to get data from a PLC, you will do like a small LabVIEW applications that talk to the PLC. And
Yeah,
that
what
will
I
be
normally
like
do is if I got a piece of hardware, I make a loop that is in charge of that hardware,
Yeah.
and is the only thing that talks to it. And I could put that in its own executable to talk to the hardware,
Yeah.
or I could put it inside the main executable. So I always start piece of hardware, thing that talks to that hardware is the first thing I do.
Okay.
Do we have time for one extra thing? What time is it? How much time left?
Yeah, you got 10 minutes, James.
So in addition to this, working with Messenger Library to get different executables, there's other things that I've been trying to work towards to really kind of like make it really work well together. And so one is the config file stuff. So if you have, say, your application is 5 executables, often you have configuration, you don't want 5 files and have to deal with 5 executables. Also, if your executables log information for a debug log, you don't want 5 debug logs, and you have to go back and forth and say, when this happened, what happened over here? You want them all to go to one log. So I have a debug logger, and I've been making sure that it works well with multiple executables logging at the same time, so that they actually come in the right order, and they are labeled by which executable it came from. And also on the config information, let's see, I use JSON text. And I've been trying to make it so that one of the problems I found with config information with things starting and stopping is lots of packages, they read the config, they make changes, and when the application shuts down, they write the whole thing. And if you have 2 executables, they both read, they both change, one writes and the other one overwrites the changes made by the other one. That's a big problem. You also have operators that modify the file while it's running, and they make changes, and those get overridden, and they get annoyed by that. So I've been upgrading JSON text so that it has a proper configuration thing where two executables can share the same file and they don't step on each other. So I can make a change. Let's see. Make some changes here. And different change. This is a different thing. And if I write, oops, oh, that's stupid. Write the config. Those are the changes. Write the config here. It actually picks up the changes. And they don't actually, if two things read it, make different changes, both write, they will not overwrite each other. Right? And if the operator opens a file in editor, makes a change, saves it, they won't overwrite that. They will, of course, fight over it. If you try to change the same parameter, obviously the last person wins. But if they're changing different parameters, which is usually what you do in a good config file, then they will actually never step on each other. And that is very useful for the multiple executables because you can modify one thing, they can share configuration information, you can modify it in one place. So I'm really trying to look at all the tooling that I use to develop applications and make it so they work properly with multiple executables going at the same time. And I guess just to get back to the way back. Oh, too late. Anyway, it's gone. Just to get back, I think that by making it easy, there are a lot of use cases that we don't do at the moment because having communication is an extra step, an extra burden that you only do when you really need to have it working on a different computer. And there's lots of reasons why, lots of value in having multiple executables that aren't just different computer. And yeah, microservices kind of thing. Yeah.
Can you have to wait for the microphone, please?
Hello, I am Met from Turkey. Can we use NI network endpoint actors instance of Messenger library?
No, Messenger Library
Are they identical, is similar?
Messenger Library is nothing to do with the actor framework.
Okay.
It uses the terminology actor because the actor is actor model, which is a computer science term that the actor framework is used. So everything that's actor-oriented design can be used in a number of different packages.
Network endpoint actor.
Yeah, that's how actor framework does it. Now, I've never used actor framework.
Okay.
I think to do that is more effort. So I'm trying to avoid that kind of thing, the kind of effort you need to use it. I want to make TCP connections between executables much, much easier than it currently is in most different ways of working.
Okay, thank you so much.
And then the exception is, the good one is like, make it so that TCP is your standard. And then even if you're in a single executable, you use TCP, which probably work.
Can you hear me? Ah, there we go. Hi, James. Yeah, I'm up here.
I don't know where you are, but
Hiya.
I recognize your voice.
Hiya. So obviously, when you've got multiple executables, you also have to deal with launching and monitoring those executables.
Yeah.
So have you got any kind of tools you've got for kind of registering those executables with kind of a monitoring service? Obviously, you touched on a Watchdog, but perhaps you could kind of talk about that, 'cause that's the other side of this.
I haven't got it totally worked out as a package, but you can use things like PowerShell and think to figure out, identify if something is running, and to force kill it or tell it to shut down and then restart it that way. So the Watchdog, of course, will execute. It actually uses TCP to tell if the main executable is working, but if it loses communication, then it will actually try and kill it first nicely, and then hard kill, and then restart. So there's a whole bunch of things you can do to keep executable. And the main executable starts the Watchdog, right? So they're a pair. The main executable starts the Watchdog, then the Watchdog is responsible for, if the main executable shuts down normally, it sends a signal, I'm done. And then the Watchdog says, fine, I'm done, I'll shut down. But if it doesn't send that and it disappears, the Watchdog will trigger and say, oh, I've got to restart it.
Yeah, it's worth looking at the .NET process library. There are some wrappers for that, I think, on the tools network, but it allows you to get like events when an application shuts down, but might kind of skip needing to use the PowerShell bit in there.
Yeah.
Okay. Now, a quick question about the addressing for the different executables. If it is on the different PCs and it has a dynamic IP addressing, can we handle it with the messaging library for dynamic IP addresses?
Well, what the thing will do is, if it changes and loses communication, it will try and reconnect. And because it's doing by a TCP service name, by a service name, rather than a specific IP address, it should then get back to it, I think. I mean, you give it a, it's, you're not using hard-coded IP addresses.
So that does it support the inter-network communication? How do we usually connect with the different networks?
Well, I don't know. One of the things I briefly showed is that I experimented with, there's a UDP address discovery, where when it starts, it sends out UDP messages every 5 seconds. I am this service at this address. And then it listens to it and uses that to figure out where everything is. That makes it easier. You don't have to configure. As long as they can get UDP messages to each other, you can just start them in any computer and they automatically connect. So that might be serve that use case.
Yeah. Thanks, James.
Yeah, over there. Right in the middle. I've got loads of questions, but I'll probably focus on the most important one. In a sort of application, so typical thing that we do is a load of black box analyzers communicating with them via TCP, serial, all manner of things. In that sort of application, would you go down the road of having a separate executable handling comms for each one of those analyzers? And if so, can you just summarize the main benefits? Because I kind of like what you're saying, but it's adding another opportunity for it not to work in my mind. So what's the main benefits? What's the problems you're solving with this approach?
Well, I really don't know it well enough. I mean, the real benefit happen with things that are like different. So this is a complicated thing that takes 3 minutes to work to start. Then it's really helpful to have that as a separate thing. You can have the same executable that each start will start a different instance of it. And by having some kind of configuration, you can configure it. So I've got 10 things, so I'll start it 10 times with different bits of information. Kind of like, I mean, again, everything you can do this way, you can do with one executable. But I think that gives you some flexibility. And you're right, if you don't trust it, like if it's an extra source of problems, then you're not going to do it. So again, that's the same thing. I want to get it so that it's good enough that you will trust it to gain the benefits, even though they're small benefits, because the cost is low enough that you would do it. So that's really, I want to get the cost of TCP communication low.
Okay, cheers.
I've got one question I had was around, have you been caught out with dealing with, hello, I'm over here.
Yeah.
Have you been caught out with dealing with more complex data types and moving them between two separate executables? If you've, say, got quite a complex type definition that you're trying to message between the two, and eventually casting or sending the data to one domain to the next, and having to either maintain a type definition in two projects or going back and forth between JSON or something else? Because that's always caught me out before when I've had to do split projects.
In my work, I tend to favor simple things. Either, like the temperature is a number. I mean, it doesn't need type def. Or if it's complicated, then it's a class. And then you do need to make sure that the class is the same on both sides. But if you're sticking to simple things, which is often the case, then you don't have the problem. In fact, you can use different versions of LabVIEW, and it's no problem. You can, I mean, if you're sending a number, it's not going to change.
Sure.
While if you have an object, then you do need to have the class definition. And if you change the class definition, you've got to rebuild them on both sides with the same class definition.
Sure, thanks.
Okay, it's about 10:30, so thank you very much, James.